Every now and then, an invention comes along that shocks the world and changes the way things are done forever. Back in the 1800s, it was the steam engine that brought about the Industrial Revolution. In our day, the closest thing we might have to this is AI. Don't worry, I'm not an AI Mike Brady. Yet. But in 1906, something happened that impacted naval warfare forever, when a new class of ship was designed that was so radical, so revolutionary, every other battleship was rendered obsolete almost overnight. Her name was HMS Dreadnought, a name which means fear nothing. The Royal Navy has always been pretty good at choosing awesome names. Dreadnought brought about changes to the design of battleships that influenced naval architects for years to come. It's a bit ironic, though, that the ship was so revolutionary when the battleship itself would, within a few decades, be rendered almost useless by the aircraft carrier. But still, when she first hit the waves in 1906, Dreadnought was the undisputed queen. What was it about this mighty ship that inspired so much change? And how did her design result in one of the fiercest arms races in history? Her career would prove as wildly unpredictable as her design was revolutionary, including a hilarious prank, a dramatic collision, and much more. Ladies and gentlemen, I'm your friend Mike Brady from Oceanliner Designs, and this is the fascinating true story of the development of the battleship Dreadnought, the warship that changed everything. In February 1906, a new hull thundered down the slipway at Portsmouth. She looked similar to many other battleships launched before her, with a vast grey hull, beautifully streamlined to eke out the most speed from her steam engines. But that was almost where the similarities ended, because the onlookers watching the ship's launch would mostly have been ignorant to her secret design genius. This was the hull of Britain's newest battleship, the Dreadnought, and the launch would send shockwaves around Europe. To really understand why Dreadnought was such a big deal, we have to turn the calendar back a few years to the 17 and 1800s. See, warships for the longest time had followed a fairly simple formula. Ships of the line were massive floating bastions of pine and oak, mounting as many cannons their decks could fit without giving way. Ships in the 17 and 1800s under Lord Nelson largely resembled their forebears from the 15 and 1600s under Drake. No, not that Drake. Yeah, that's the one, thank you. They relied on sails and the wind, so they were at the mercy of the sea, and they were limited to slow speeds. Their cannon had ranges out to just a couple of 100 yards and fired either solid shot, cannonballs, or special shot designed to take down the enemy's masts and rigging and leave them helpless. Now, these limitations meant that for hundreds of years, ships of the line would close to almost point-blank ranges and engage in roaring gun duels, firing into one another's hull and sending boarding parties to kill and capture. It was really gnarly stuff. In fact, if you've seen the movie Master and Commander, one of my absolute favourites of all time, you'll get some sense of what I mean here. But that's just the way it was for a very, very long time. Advancements in ship design were few and sluggish. The admiralties of France, Britain, Denmark, Holland, all the big ones, they were usually slow to react to change. Things had worked just fine for centuries. Why mess with the formula? Well, in the early 1800s, they were forced to pay attention because suddenly ships were chugging around powered not just by the wind, but by steam engines. The advantages were obvious. Now, warships weren't totally at the mercy of the wind and the waves. Where frigates and big three-decker gunships alike might once have been stuck for weeks on end in a calm without any wind, suddenly steam-powered sloops and other vessels could forge ahead with no worries. Soon enough, the steam engine meant advancements in iron, and eventually steel construction could also be made. Within those few heady decades, warships had gone from looking like this to this. Okay, well, the outside might look vaguely similar, but the propulsion inside was hugely, hugely different. What wasn't very different were the guns. See, for a while there, steam warships were essentially just Napoleonic frigates kitted with steam engines. They still relied on those old cannons to hurl iron balls into the enemy at close range, but that was soon to change. In the mid-1800s, some advancements were made in gun design that would change everything. Suddenly, some bright sparks came up with the idea of rifling gun barrels. It meant that shells could grip the grooves inside as they were fired and spin through the air with significant advantages to both range and accuracy. Suddenly, cannonballs were a thing of the past. And crucially, these new guns were loaded not at the mouth of the barrel, but at the back in the breech of the gun. Now, this could also speed up the reloading process and improve standards of safety. Soon enough, some other bright sparks floated the idea of putting these new breech loaders into turrets that could swing around and the turret warship was born. Now, these new ships could fire in almost 360 degrees, and they didn't need to creep up on their enemy to point their ship in the direction the guns needed to fire. Now, the turret ship, as it was called, had a bit of a troubled history, especially in the British Royal Navy, where some teething issues resulted in some rather unhappy designs getting approved from construction. Now, we did a video on HMS Captain, you should check it out. But eventually, the formula had been refined, and by the late Victorian era, warships were heavy, fat, squat things powered by reciprocating steam engines with turrets that could fire in all directions. They weren't very seaworthy, to be sure, but sails were now a thing of the past too, and the modern battleship was born. It had been a remarkably short path to get warships looking like this to this within less than 100 years, but at last, iron-hulled, steam-powered, turreted battleships ruled the waves. Try saying that 5 times quickly. The only issue was that in that latter part of the 1800s, they saw very little actual combat, so navies and admirals had these fancy new toys with only vague ideas of what they were actually capable of. They got some idea during the American Civil War, when the ironclads USS Monitor and CSS Virginia went toe-to-toe in a lengthy, fruitless engagement with neither able to really penetrate the iron-armoured hull of the other. The takeaway was that guns needed to be able to outperform the armour they were firing at, so the race between armour and gunpowder erupted, and at first, armour won, as shells bounced uselessly off of hull plating, but slowly the naval gun became larger and more powerful, and scarier. By the late 1800s, battleships could fire shells out to a distance of 6,000 yards, that's over 5 kilometres away, and they were, for a time, the undisputed kings of the ocean. That is, until a little invention came along called the torpedo. Now, don't worry, we are making our way to the Dreadnought, but now we need to talk about this fancy new invention because it shook everything up. Battleships were at this point big, fat, slow, floating castles festooned with guns of all kinds of calibers, adept at smashing through armor plating. Did I mention they were slow? Yeah, they were pretty slow. Usually featuring pairs of expansion steam engines, late 19th century battleships might have been capable of maximum speeds up to 16 knots, which was pretty impressive for the day. But the introduction of a new kind of warship made them sitting ducks. The torpedo boat burst rudely onto the scene in the late 1800s, a small, fast, steam-powered vessel capable of cracking top speeds, but little bigger than a small private yacht. Now this, you may think, might have made them sitting ducks themselves. Of course, a single hit from a battleship gun could easily send them to the bottom. But they fielded a fearsome new weapon. That new invention we mentioned earlier, the torpedo. The torpedo boat was a sensation when first introduced, and the world's navies stocked up rapidly because, in theory, swarms of fast, cheap torpedo boats could encircle lumbering, expensive battleships and escorting cruisers, send fields of torpedoes roaring towards them, and cause all kinds of havoc with the sluggish battleships unable to turn in time to avoid them. Now, this is the kind of tit-for-tat arms race that was kept up through the 19th century and into the early 1900s, as all kinds of new technologies were dreamt up, tested and implemented for the first time. Of course, we all take this for granted now. The concept of a torpedo or a battleship is all pretty common knowledge, but try to put this into context by remembering that the grandfathers of captains aboard late Victorian battleships would have been at sea aboard the likes of HMS Victory. This was also new, so daring. A few visionaries in the British Admiralty knew it, and they were driving for change. So it was, by the early 1900s, that the Royal Navy was presented with the following problems. First of all, battleships had begun to mount large secondary guns. They were smaller caliber weapons than the main armament, but during shelling though, the rapid fire of the smaller secondaries could often obscure the target with the amount of shell splashes. This of course in an era where adjustments to fire were entirely visual. Not only that, but the advent of torpedoes meant that battleships would need to engage from further away to reduce the risk of attack. Now this range increase would render the secondaries useless anyway, it was thought. Not only that, but the battleships would need to be fast, sleek, and speedy enough to get into position, hit the enemy battleships and cruisers hard, and get out before a mass torpedo assault could be mounted in response. The basic shape of the battleship would need to change, and so too the kinds of guns it should carry. In the early 1900s, some visionaries, including the Italian naval architect Vittorio Cuniberti, began to advocate for an all-big gun battleship, a return to the days of old when a battleship's main duty was just to lob heavy shells. In theory, a battleship would be escorted by cruisers and other smaller warships anyway, so they could act as the secondary guns. He presented his ideas first to the Italian Navy, who rejected him, and then to the public in a popular journal. His proposal called for a large ship, sleek and lean, displacing about 17,000 tons, capable of 24 knots and fielding no fewer than 12 huge 12-inch guns paired in turrets. Now, this concept was, for the time, basically pulling numbers out of Cuniberti's hat, because getting a battleship up to that speed must have seemed an impossibility. Still, Royal Navy battleships had begun to get slimmer and sleeker, and therefore faster. Although they were still powered by triple expansion steam engines, HMS King Edward VII and her sister ships, built in 1902 and introduced in 1905, could scream along at 18.5 knots, which was a great improvement, and they were much more hydrodynamic than the stubby old warships of the late 19th century. Actually, here's an interesting side point. Remember when I talked about the battle between guns and armour? Well, for a while there, it was thought that ramming an enemy's ship could do more damage quicker than simply shelling them, so many warships were built with reinforced ram bows. The HMS King Edward VII and her sisters were some of them, but the ram bow had an unexpected side effect. It cancelled out the ship's bow wave to some extent, reducing drag through the water. It made the ships faster and more efficient. Now today, we use this kind of bow on most, if not all, big passenger cruise ships. They're called bulbous bows. Anyway, King Edward VII was quick and sleek, but she only mounted 4 main 12-inch guns and a spread of secondaries up to 9 inches. Now, this of course meant that in a pinch, with her bow pointed at the enemy, she could only get 2 guns on target at maximum combat range. The British sought to rectify these issues with a new kind of battleship, but they weren't alone. It has to be said that so too did the Japanese and the United States. All three were major naval powers at the time, and they recognised the same opportunity. The designers got to work, and history was about to be made. The idea of the old big gun battleship had a powerful proponent in Britain. First Sea Lord Jackie Fisher had called for such a design around the turn of the century. He had read keenly about the Japanese fleet in action against the Russians in 1905 and taken some key lessons away. First, he knew that 12-inch main battery gunfire was hugely important in dealing massive amounts of damage to the enemy. But he also became obsessed with speed. Outmaneuvering the enemy would be a massive advantage to any battleship fleet. Now, this new breed of battleship needed to be quick. Unfortunately, the British had just the kind of mechanical ace up their sleeve that would give them the speed they needed. In the late 1800s, engineer Charles Algernon Parsons, Algernon is such an awesome middle name by the way, began to perfect a new kind of engine. Conventional reciprocating steam engines at the time used huge cylinders to expand steam under pressure and shift their pistons up and down. This movement, like the engine in your car, would then drive a crankshaft attached to propellers down long shafts. It was a mechanically reliable concept, but there was a cap on how fast it could really drive a ship. It was clunky, used a lot of heavy machinery, and took up a ton of space inside the hull. Parsons designed a new kind of engine, however, the steam turbine. He figured you could simply place a large cylindrical rotor covered in fan blades inside of a casing and then blast steam under very high pressure through it. The blades would spin the rotor very quickly. Extremely quickly, in fact. His early tests got his turbine spinning at up to 18,000 revolutions per minute. His idea took some time to take off, but he demonstrated the concept dramatically in 1897 when he showed up unannounced aboard his test boat, the Turbinia, at Queen Victoria's Diamond Jubilee Naval Review. Now, like a speedboat, Turbinia roared up and down the lines of old battleships, and the stunt encouraged Admiralty attendance at formal speed trials. Eventually, the turbine was accepted for use on some smaller warships where it proved a powerful engine capable of achieving, when paired with a sleek hull form, impressive speeds. Now, it had never yet been used on a warship exceeding 340 tons. In 1904, the turbine was installed aboard an Oceanliner, Allen Line's Virginian, for the first time. Eventually, it would go on to power the world's fastest ships, from Mauritania and Lusitania up to the Queen Mary and the United States. But remember, for the sake of our little story here, that the year now is just 1904, and this newfangled turbine is still a contraption yet to be fully proved. Fisher and the Admiralty took a bit of a leap when they decided to equip their new battleship type with the Parsons turbine. In fact, so new was the technology that Vickers, the primary contractor for machinery and naval contracts, deferred instead to Parsons directly. The 4 turbines were paired and drove 4 propellers, outputting some 27,000 shaft horsepower. It was hoped that the new battleship would be able to hit speeds of up to 21 or 22 knots, because the powerful new turbine engines were also lighter than the older style triple expansion steam engines. In the end, the decision to use them resulted in a power plant that was 1,100 tons lighter. The sleek hull was tested with large models in the Admiralty test tanks, and the result was a thin, fine hull form. Now, it's a good thing the turbine machinery installation proved to be smaller too, because the new battleship would need all the extra space she could get because the plan for her guns was just as radical. Now, conventionally, battleships from the time with turrets had mounted a pair of guns forward and a pair aft. Then astride the ship's centerline, sets of secondaries were arranged along the hull. Now, this was an effective use of space, but it meant that if the T of the battleship was crossed, that is to say, if the enemy managed to cut across the battleship's bow and pour a full broadside into her, the responding battleship could only answer with 2 of her main guns pointing forward. Fisher and the Admiralty decided to finally implement the all-big gun battleship concept that Cunibert had been talking about to counter this uncomfortable position. First, the secondaries, the larger secondaries, were deleted. The new battleship would be longer than the preceding King Edward VII class. The longer hull form would cut cleanly and more hydrodynamically through the water, but she would also be wider. Now, this was for good reason. Now, on the battleship's beam were mounted another pair of main gun turrets, both with twin 12 inches. The forecastle deck, the higher forward end of the ship, was slimmed so that it didn't reach the extreme edge of the ship's sides. Instead, the 2 new gun turrets could aim right down the centerline and fire forward to back up the first gun turrets, or swivel right around to fire aft. It meant that if the new battleship crossed the enemy's T, she could pour heavy shell fire from no fewer than 8 12-inch guns, double that of the previous generation of battleship. Now, this is where the genius of the new battleship truly lay. She could pour fire onto the enemy. If her T was crossed, she could get 3 gun turrets on target. A fleet of this new brand of warship would be devastating. Once they'd outmaneuvered the enemy, the volume of fire at range would be devastating. Work began in October 1905, and such was the importance of the project that she was ready for launch just 4 months later, and then completed within a year of her launch. Now, this was achieved at great expense to the comfort of the work crews, who were, first of all, doubled in their strength, and then had to work double shifts themselves, with only 30 minutes for lunch. On the ship's nameplate was the fearsome moniker Dreadnought. In fact, she was about the 10th Dreadnought of the Royal Navy, but her name would soon come to carry greater significance. Upon completion, the all-important speed trials began, and this would prove whether the whole thing had been worth it. With turbines whining incessantly, the ship roared ahead at nearly 22 knots, almost as quick as the fastest ocean liners of the day. Now, this was a great achievement, and Parsons' turbines absolutely proved their worth. Dreadnought was quick, and she was mean. Her guns were guided by another technological ace, her electric fire control. In the past, getting guns on target meant the use of optical rangefinders to manually calculate correct trajectories and range to target, which would then be yelled into a megaphone or a telephone to the gun crews. Dreadnought introduced an electrical system which could transmit the orders directly to the turrets over the din of the gunfire. Observational data was put into a kind of mechanical computer that relayed that data into a translated firing solution direct to the men at the guns. It was a brilliant bit of technology that meant Dreadnought could put up to 8 of those big 12-inch guns onto target with alarming accuracy for the time. Dreadnought brought a few other changes as well. Steel thicknesses in the hull plating and her armour were standardised and reduced to as few variations as possible. It helped to speed up her construction. In fact, the very speed with which Dreadnought came together was supposed to show off Britain's engineering might, never mind the poor workers who had sweated and toiled for months with very few breaks. So, HMS Dreadnought had burst unexpectedly onto the scene, and her abilities were being wildly proclaimed by engineering journals and the likes of popular books like Jane's Fighting Ships, who proudly boasted Dreadnought's capabilities were the equivalent of 2 or 3 older, conventional battleships. In fact, Dreadnought's speed and abilities were so good that Admiral Fisher's former naval assistant reported that no member of the Committee on Designs dared to hope that all the innovations introduced would have turned out as successfully as had been the case. Now, this was largely true, but of course it represented a good bit of British bluster. The ship was not perfect, and she certainly had her deficiencies. For one thing, she sat so low under heavy loading that her main thick armoured belt slipped beneath the waterline, meaning her thinner upper belt would be the vanguard against dangerous shell hits. But worst of all, she was extremely uncomfortable for her crew, especially her officers. A lieutenant recalled that the mess decks were small and cramped, that it was clear crew accommodation was more of an afterthought by the designers. Her officers had to walk from their quarters at the bow of the ship the full length just to go to the toilets or heads at the stern of the ship. Now, despite these teething troubles, Dreadnought's appearance came at just the right moment for the Royal Navy, as it did for the State Secretary of the German Imperial Navy, Alfred von Tirpitz. He had been assisted by the Kaiser in passing bills to build more German warships, but it hadn't been easy. In 1895, for example, the Reichstag approved funding for only 4 of the 36 cruisers proposed for construction. In 1905 and 6, though, things were different. German nationalism was being driven to fever pitch. The Dreadnought challenge had to be answered. Tirpitz's proposed 35% increase on naval spending was approved, and then, in 1908, another bill that guaranteed 3 or 4 battleships would be built per year. Now, critically, they wouldn't just be any old kind of battleship. They would, of course, be dreadnoughts. Fast, heavily armed battleships designed to bring as many guns to bear on target as the British warship could. From that point on, any battleship built prior to 1906 was known almost derisively as a pre-dreadnought. So revolutionary was the combination of Dreadnought's components that she became a very class of ship unto herself. The kind of tit-for-tat arms race that followed as Britain and Germany pumped billions into their navies led almost directly to the tensions that caused the outbreak of the First World War. In fact, so fast was the rate of development that pretty soon Dreadnought herself was eclipsed by newer styles of battleship that built upon her once impressive platform. Now, you may ask yourself, surely a ship as decisive, as revolutionary as the Dreadnought would go on to have a spectacular and extremely eventful career? Well, no, the answer is not really. True, in the First World War, she did ram and cut a German submarine in half. But the Oceanliner Olympic did that, and she was hardly a fearsome war machine. No, the thing Dreadnought is most famous for is a practical joke. In 1910, some visiting delegates from Abyssinia, modern-day Ethiopia, were invited to tour Dreadnought. They were greeted by an honour guard and officers in full dress uniform, shown around the fleet, and of course the flagship Dreadnought herself. Now, the only issue was that the Abyssinian delegates were actually English university students in bad makeup and costume pulling a prank. They spoke in gibberish, and if they're shown something exciting, they loudly exclaimed, "Bunga bunga." Now, years later, in the First World War, when Dreadnought did ram and sink the submarine U-29, one of the congratulatory telegrams supposedly read, "Bunga." Now, aside from that action though, Dreadnought proved to be that one friend you can't seem to get along to a social catch-up. When the Battle of Jutland, possibly the most epic naval engagement of modern history, happened in 1916, Dreadnought was in for a scheduled overhaul. In a final kind of ignominious slight, Dreadnought saw out the rest of the war, providing coastal defense alongside a fleet of, you guessed it, pre-Dreadnought battleships that she had once helped eclipse. So it was that the most revolutionary battleship design of the early 20th century was reduced to little more than a reserve ship. In fact, that kind of mimics the story of the battleship as a whole. They proved instrumental in the First World War, but the Second World War, less than 20 years later, would essentially render them useless, and some of the greatest battleships in history were attacked and sunk by swarms of aircraft. HMS Repulse, the Prince of Wales, Bismarck, Yamato, and Musashi, they were all turned to rusting scrap metal on the seafloor by airplanes. Still, despite the realities of her service career, Dreadnought did her job well. She was a testbed for technologies that by themselves were not entirely revolutionary, but when combined into one, totally changed the game. She may not have seen heavy combat, but she still engaged her enemy, and she did earn a victory. Her very existence set off a chain of events that resulted in massive military spending and one of the mightiest clashes in military history. So, to HMS Dreadnought, we can say a final job well done, and bunga bunga, indeed. Ladies and gentlemen, it's your friend Mike Brady from Oceanliner Designs. Thank you so much for watching this video. If you enjoyed it, please leave a comment below. And don't forget to subscribe to the channel because we get new videos out weekly. If you want to support my work and get really cool perks like behind the scenes and early access, please visit my Patreon in the link in the description below, or sign up as a YouTube member. Come and join the crew. And as always, stay safe, stay happy, and I'll see you again next time.